Okay, so we've got through some graphing and then we started to talk about something called intercepts. What I've done is I've left up from a few slides ago, I've left up the work we did to solve, create the graph for y equals 3x plus 2, right? So instead of taking that down, we'll move to green. I didn't graph it using intercepts, although I happen to use one intercept, right? So what an intercept is where the graph crosses the x-axis and the y-axis. So in this case, the graph crosses the x-axis, and we'll make it really big. You'd never make it that big if you were graphing it, but I want you to see it easily. And where it crosses the y-axis right here, okay? So that's the two places, right? So if I wasn't just choosing points like I did in the last one, and we'll see if we can rub this out carefully. See if we can do this. Okay. If I didn't just get to choose whatever I wanted, but the question asked me to find the intercepts, what I would need to do was I would need to find where the graph crosses the x-axis. And whenever it crosses the x-axis, you'll notice the vertical value, up and down, is 0. And that's what this slide is talking about. It's saying, all right, we'll use green here. It's saying when y equals 0, what's x? Because this will get us the x-intercept. Okay? To find that x-intercept, we have to say when y equals 0, what is x? Okay. Now, we can do that. We can take our equation. We'll do it in blue. We'll do it in red. So, we'll take our equation. And we say when y equals 0, what is x? Well, when y equals 0, we have to put 0 in for y. And then we solve this little wee equation, we isolate for x. Okay? So we move 2 to the other side, we subtract 2 on both sides. Remember, when you're moving it to the other side, it becomes a negative. And that's 3x. And then when you're getting x by itself, okay, just a little reminder, getting x by itself, you have to divide both sides by what's ever in front of the x, which in this case is 3. Okay. So x equals, well, it looks to me like x equals negative 2/3. Okay, that's x. Well, so when y is 0, x is negative 2/3. Well, how did that plot? Well, yeah, so x, I kind of messed it up over here. It's actually over here a little bit. So between 0 and 1, that is negative 2/3. It's 2/3 of the way between 0 and 1. So x is negative 2/3, and then y is 0. Y doesn't go off the axis. In the very same way, okay, if I wanted to find, I've got a little too many markers here, if I wanted to find the y-intercept, okay, the y-intercept, notice it touches the y-axis, and whenever it touches the y-axis, x is 0. No matter where it touches the y-axis, x would have to be 0. So when you ask the question, when x equals 0, what is y? That's what you're asking. Okay? And we know the answer is going to be 2 because we've already got it from the last time we did the graph. But let's have a look at it. So when x, so we have our equation, and we're saying when x equals 0, which means we need to put 0 in for x, what's y? Well, 3 times 0 is 0 plus 2, and it looks like y is going to equal 2. Which we knew it would, right? But so when x equals 0, y equals 2, so 0 and 2 is our intercept. Right? So now we're done, kind of. But if the question says find intercepts, why am I finding this third point called a checkpoint? And you'll see it on yours, they use the checkpoint like negative 2 and 6 2/3. Why am I finding a checkpoint? And the reality is, because if I find 2 of them, I can draw a straight line. But if one of them is wrong, I won't know if my straight line is right or not. But if I find a third point and all 3 points line up, then I know that my intercepts are both correct. If I find a third point and it happens to be over here, then I'm thinking, one of these 2 points is wrong. Or maybe I made a mistake there. So how do you find that third point? Well, you take any other point, not when x is 0 and not when y is 0, right? So I'm gonna use a checkpoint. And I'm going to use one we saw a couple slides ago. I'm going to say when x equals 1. I mean 1. I'm getting ahead of myself. When x equals 1, okay, find y. Well, we have y equals 3x plus 2. X equals 1. 3 times 1 plus 2. And 3 times 1 is 3 plus 2 is 5. And there should be no surprise that when x equals 1, y equals 5, because that was a point that we found before, right? So x equals 1 and y is 5. And it is no surprise right there. And our points line up. So we've used our intercepts to graph a line. And we've checked it to make sure it's correct. Okay? That's the last video for this week. There are a couple more as I go forward. There's just a couple more examples of using intercepts. But that's the last one for this week. I hope you have a great week. We'll see you again for week 12. Take care.